Welcome to In 5 Minutes. The agenda of this clip is to implement a clocked SR latch or latch with an enable signal in different styles such as Pseudo Nmos, dynamic logic and CCMOS logic. Okay, let's get started. In the previous clip, we have already seen how to implement the clocked SR latch at the gate level, the diagram which is present here. We also saw the implementation of the same at the static CMOS style level, where we understood that we labeled all these 4 NANDs like NAND 1, NAND 2, NAND 3, NAND 4 respectively. We also understood, or we also knew how to implement a CMOS NAND, and we replaced this gate level diagrams with the transistor level diagrams and just gave the inputs and labeled the outputs and made the required connections. So this we have already seen in the previous clip. Now we know that for Pseudo Nmos style, the way this circuit will be translated is we will remove our pull-up network and will replace our pull-up network with nothing but just my PMOS transistor with its input grounded. Once we do this, this will be nothing but my Pseudo Nmos style SR latch with an enable signal. Let's quickly do that. So this is nothing but the same circuit where the pull down remains the same, whereas the pull up is replaced by a PMOS transistor with its input grounded. So this is nothing but SR latch with an enable signal in Pseudo Nmos. Now we will go ahead and make this in dynamic style. Now what do we, in dynamic style. What do we know in dynamic style which is different from static style is below there will be a pull down transistor NMOS and above the pull up would be, so let's say pull down transistor NMOS would be connected in series below, NMOS in series below. So this is one thing which will be a change in dynamic. Another thing which will change is the pull up network would be replaced by a PMOS having its input as clock or phi, and the same input will go to this NMOS transistor as well, which is connected in the pull down network, and this will become my dynamic circuit. We have already studied the basics in the previous clips. Let's quickly go ahead and make this schematic. So this is nothing but my pull up transistors PMOSs given the inputs phi, and I've added an additional transistor in the pull down and give it also an input phi, which is nothing but an NMOS, and in between the logic is same as the pull down logic of the static CMOS. So this makes it very simple. This is SR latch dynamic circuit. Now let's quickly go ahead and make an SR latch C2MOS circuit. Now we know that for C2MOS, what changes is in between the pull up network of static and pull down network of static, we append or we connect an additional PMOS and an NMOS transistor in series to the pull up and pull down network, and in between the two we take our output. So this is nothing but my C2MOS logic style, where this is going to be my phi and this is going to be my phi bar. Both of them would be complementary to each other. So let's quickly draw a C2MOS style where the pull up will remain the same, the pull down will remain the same, and between pull up and pull down we'll have an additional PMOS and an additional NMOS transistor. Let's quickly do that. If you see, this is my pull up of my static style, this is my pull down of my static style, and in between I've added a PMOS and an NMOS at all places, and this is nothing but SR latch in C2MOS style. Now if you see here properly, I've deliberately made an error so that you don't make this error in your exams. A lot of people tend to do this, and that's the reason I have done it deliberately. The output is, remember, the output is not taken from here, the output is not taken from here, the output is not taken from here, and the output is not taken from here. The output is taken from between the PMOS and the NMOS transistor, the additional ones which are appended. So these are your 4 outputs. In this case, this is my S bar. In this case, this is my Q. In this case, this is nothing but my Q bar. And in this case, this is nothing but my R bar. So Now this S bar will go to the respective S bars, this Q will go to the respective Q, this Q bar will go to the respective Q bar, and so on and so forth. So remember, this is not the right connection and don't make this error in the exams. Hope you have followed the latch with an enable signal in different style. In further clips, we will see latch with an enable signal in pass transistor logic and transmission gates, and we'll also see an SR flip-flop. Thank you very much and stay tuned for further clips.